Hey guys, this is 4.4, just some basic instruction into the concept that we're dealing with here in 4.4. In 4.3, we were trying to figure out where a parabola crossed the x-axis. And it was really easy to just factor it and find those solutions. In 4.4, we start dealing with solutions that include fractions. You know, when it crosses at exactly 1 and exactly 5, it's great. But what happens when it crosses at 1.5 or maybe negative 2/3? Okay? You know, what happens then? How do we find those solutions? Because they're not whole numbers, and factoring suddenly gets a little bit more complicated. The basic idea is that we're dealing with things like 3x squared, okay, plus, 8x minus, actually we'll go plus 4. I think that'll work. I'm making this up as I go. But it's the concept of how do we factor something like this? The problem is, you know, we can't split it as x times x because x times x doesn't give us the 3x squared. It just gives us x squared. So we have to include that 3 somehow. Now traditionally what's been done for years is we split it as x and 3x, and then we guess our way through. You know, this 4, it could be a 1 and a 4, it could be a 2 and a 2, and your guess is as good as mine at determining which one are we going to use. The more of them you do, the better you get at it, but deep down, it's hard to guess and be accurate all the time. And so we might try 2 times 2. I'm going to use these 2's here to be sure that we're right. That's sort of our guess. Now we have to check our answer. And the way we do that is by checking the middle. If you think about FOIL, it's the O and the I from FOIL, the outer and the inner. 2 times 3x is 6x, and x times 2 is 2x. Those numbers add, this is really important, that 4 is positive, so do they add to 8? The answer is yes, they add up to 8x. So I have the numbers in the right spot. I still have to get my signs associated correctly, but at least the numbers are where they belong. And that, you know, right here we go 4, and 4 is positive, so the signs match. To get a positive 8, I'm going to need some pluses. And so we factored it, and that's great. If we get to the section where we're asked to solve, we actually have to go one step further. We'll say that it equals 0. In the section where we're asked to solve, rather than just factor, you know, it's the same as what we did before. You know, you got x plus 2 and 3x plus 2. You know, this one right here, we switch the sign of the thing with x. We can say that x would equal negative 2. But there is a second answer, and it's not negative 2 again. This 3 is going to affect our answer. If we think about that being equal to 0, the first thing we would move is we would subtract a 2. That makes sense. We would move the 2 over. The next thing we'd move from this parentheses would be this 3, and we would do it by division. So we're going to divide that number by 3. And there are our 2 answers. Now this is great, and the truth is I got lucky and it was easy to factor. The truth is there are going to be a lot of problems that aren't easy to factor. And if you struggle with this type of factoring at all, I want to show you a new trick that Mr. Worth showed me that I think can save us some time. I realize that if you're really comfortable with factoring, this isn't going to seem like it's going to save you time. But if you struggle at all, this is an option that's going to make it a little simpler. We take the same problem, 3x squared plus 8x plus 4, and we're going to multiply the 3 times the 4. And I'm still in the 3 from the x squared, so now I'm just going to have a regular x squared plus a regular 8x, but now it's plus 12. Okay, so we've changed the problem. There's going to be a price to pay for this multiplication by 3, and we'll pay it a little bit later. But the factoring is now easy. It's as easy as it can get. X and x. How do you split a 12 so that it adds up to 8? Well, that would be a 2 and a 6. Okay, we could try 3 and 4, but that's only 7. 2 and 6 is our best option. So we put a 2 and a 6. The sign for 12 is positive, which means the signs have to both be the same. In order to get a positive 8, I'm going to need a plus 2 and a plus 6. Now, it's been factored, but we never really dealt with that multiplication by 3 that we did earlier. That times by 3, we now have to pay the price for it. The way we pay that price is by dividing both of our numbers by 3. We multiplied by 3 to get them. Now we have to divide the 3 back off. On the one on the right, it's actually pretty simple. It's x plus 6 divided by 3 is 2. And you guys can see that same parentheses exists over here. On this one, we have to remember that the x squared was never really just an x squared. It was always a 3x squared. And since this one has just a regular x, this is clearly got to have a 3x. So if you think about it this way, that 3, it couldn't divide into the 2. So we just slid it up and put it next to the x. Whenever it doesn't divide evenly, we just slide the number up and we move on. If you think that's faster, any better, awesome. Do it. It's great. Now, when it comes to solving equations, a couple things have to happen. First, it must be equal to 0. So to solve, must equal 0. Okay? So if it's, equal to 5x, we've got to move the 5x over. We've got to move everything to one side. Okay? Occasionally, not very often, but occasionally you're going to find problems that aren't really ready to be factored this way. Let me give you an example. Let's say I had 2x squared plus 4x plus 2 equals 0. You might notice that all of these numbers divide by 2. If I can divide everything in a problem by a set number, that's a great option for me. So I'm going to divide by 2. Okay, so when I divide this by 2, it's going to become x squared plus 2x plus 1 equals 0. And now it's ready to factor. So every now and then you'll notice that all the numbers divide by a set number. The other thing that you'll notice from sometimes is you'll end up with something like 3x squared minus 3x equals 0. Notice it doesn't have a constant. If you're ever missing a constant, the number at the end, you're going to do what's called the Gcf factor. You're going to factor out what's common. What do these two have in common? Well, let's change this. Let's get rid of this 3 here. Let's just say we had this. X squared minus 3x. What do they have in common? The thing they have in common is an x. And so we would pull an x out and just create one parentheses. If I pull x out of x squared, it would be an x. Think about distribution, right? If you think about boop, you get an x squared. If you pull an x out of a minus 3x, you should be left with minus 3. And if you think about the distribution, yeah, that makes sense. If we take an x times a negative 3, we get negative 3x. So then when it comes to finding the solutions to these two, this one's obvious, x equals 3. This one right here sometimes confuses people because it doesn't really have an addition or subtraction with it. That's the key indicator. It doesn't have any added or subtracted values, which means that it's 0. It has no set value, so it's at 0. If I were to graph this, okay, these kinds of problems, it obviously crosses here at 3, and it crosses here at 1. And so we would see something like that. Or at 3 and at 0, sorry. Well, hopefully that helps you with an understanding of what we're after, and the homework video might help you with some specifics on the assignment. Good luck, and we'll see you in class.